All right, just another day of school closure, talking to a bunch of empty seats in my classroom. Not the funnest day. Hopefully this will help my students who are sitting at home though. My students are going to start on an assignment today on exponential functions. This is the first time they're ever going to see an exponential function. First thing I want to talk about is models. So we know that a constant function is a flat line, it's constant, all right? We know that a linear equation has a constant rate of change where it has this constant staircase where it's over, up, over, up, over, up, the same amount repeatedly, which is addition. So I'm gonna put that right here, that would be addition. It adds 4, adds 4, adds 4, adds 4. Takes away 2, takes away 2, takes away 2, depends on what the slope is. My students have done quadratics, where you got smiley frowny faces, or mathematically parabolas. They've also seen polynomials, where you got a whole bunch of fun stuff going on, where this would be a 1, 2, 3, 4, 5. This would be a 5th degree polynomial. So we've seen some of that fun stuff. But now we're in exponentials. And the exponential model, it's going to have 2 different models. So let me draw 2 bigger grids. It's going to have 2 different types of models. We're going to have one for put that down. We're gonna have one for growth, and we're gonna have one for decay. So for growth, it's gonna start low and then grow exponentially. Decay is gonna start high and then come in and decay exponentially. All right, so it's not a flat line, it's not a straight line, it's not a frowny smiley face. It's got this very specific curve that exponentially decreases or grows. Okay, so let me erase these top models because we're not going to talk about those. All right, so here is the general form, one of the general forms. The general form that I'm going to start with my students. It's going to be y equals a times b to the x. All right. Now, looking at these 2 models, hopefully everybody who's watching this video can identify one key point on this model and on this model. And that key point would be, is the y-intercept. Now the y-intercept represents what the y value is when the x is 0. Now in most application problems in Algebra 1, maybe pre-algebra and some other math classes you might have had, is when you start at 0, or for application problems, you usually start at 0 and then go on. Because usually we talk about positive things. We're gaining things, something's happening over time. Usually we're going to be talking about quadrant 1. So that means if we're talking about just quadrant 1, that would be the starting point. And that comes in here because this will be A. That is A. Let me draw that a little bigger. I don't know how well this shows up on the video. That is A. All right, and A is going to be the initial amount. All right, so let's get a key going over here. Y will be the ending amount. A be the initial slash starting amount. B is going to be the growth slash decay factor. All right, and let me grab this guy. So yeah, I should get rid of this for now. And X, for exponentials, for all the stuff you do with exponentials, it happens over time. Things grow and decrease over time. There might, every once in a while, be an application where it's not going to be, where this isn't going to be time, but for my students, for the rest of this school year, this is always going to be time. So X is time. It's the amount of time that has passed. Let's get some blue up here also for notes. So that goes with the function. I do need you to remember, because my students are going to have some problems where they need to identify the exponential function or identify whether it is or is not exponential. So exponentials, we got this, or we got that. All right, that's what they look like. I mean, rough estimate of what they look like. Now, the other types of problems that this video is supposed to help my students with are identifying key components of this when given context to this. So if I give a problem, let's say 4,000 equals 200 times 3 to the x. There's going to be 3 things that you can identify from this. The only thing you can't identify from this is I can't identify the time, because I don't know what the time is, because it's still x. So that one's out. I can do b. I know what b is. B is equal to 3, comma, because I won't be done with that. Now, b is a growth or decay factor. So the next thing my students are going to have to identify is this growing or is this decaying? Well, one way to do this, if you don't know the math, is you push this into a graphing calculator, Desmos graphing app, if you've downloaded that on your phone or your graphing calculator, and you would see that it is growing. The other way is, let's add a few other notes. And I'm not going to get into the math behind it in this video, but I will in the next video for exponentials. But for now, just know that this holds true. So if b is greater than 1, it's growth. And it's decay if b is in between 0 and 1. So 0.1, 0.2, 0.3, 0.4, 0.5, all the way up to 0.9, 9999. If it is less than 1 or greater than 0, in between this interval, decay, growth. So that goes to that guy. All right. So 3, greater than 1. So this would be growth. I can also say what A is. So A equals 200 starting amount. And then I also know how much it ends with, because that's what Y is. So after some random amount of time growing, whether it took This is, if it was in years, whether it took 20 years, 10 years, I don't know. I don't know how much time it took. We don't know. But I do know that y equals 4,000 ending amount. Forgive my poor grammar and spelling down there. All right, so 4,000 ending amount. We have A, which is my starting amount. I have 3, which is my growth factor because it's bigger than 1. All right, I'm gonna do one more example. And then I'll cut this video off because that's what my students will need to know this week for their assignment. And then I'll upload another one to continue on with exponentials. So let's do a decay one this time. So if it's gonna be decaying, that means I'm gonna have to start with a bigger number and end with a smaller number because it's decaying. So let's do, I don't know, we start with 50, I ended with 10, which means I need to decay, which means I need to pick a b value that's less than those. So let's do 0.8 to the x. All right. So I know what b is. So b is equal to 0.8, and that would be decay. Well, my next video will be is, oh, I decayed by 20% because I have 80% left, and that'll be in the next video. My A was started with 50, and then Y ended with 10. All right. So what my students need to know is how to identify an exponential. You need to be able to identify the exponential. If it's linear, if it's quadratic, if it's cubic, you need to be able to pick out of a multiple choice problem which one's the exponential. And then you need to understand when given an exponential function in this form, how to identify, let's say I ask you, what is the starting amount? Well, the starting amount is 50. You need to be able to identify that. You need to be able to identify whether it is growth or decay. All right, you need to be able to identify whether it's growth or decay based off these two. Oh, that one's growing, this is growth. That one's decaying, that one's decay. This is less than 1, it's decay. Let's do, I don't know, 4/3. That's greater than 1, so it's growth. Okay, I hope that helps anybody who's watched this video. Hopefully it helps my students with their assignment.